Hello and welcome students. This is lecture number 13. This is lecture number 13 on differentiation. And right now we are working on logarithmic functions, derivative of logarithmic functions we are working on. So uh, I am, for solving problems, I am taking the reference of a textbook, which is Maharashtra State textbook. I'm taking Maharashtra State's textbook and the concepts are almost similar, whether it is Maharashtra State textbook or it is NCERT textbook. The problems are also same. So here, let us start with. Right now, I am in exercise 1.3. We are in exercise 1.3, and in this exercise, I am in question number 2. So here, from question number 2, there are several questions in this. In question number 2, there are total 8 sub questions. I shall be taking for you question number 3. So here it says differentiate. The question is differentiate the following with respect to x. And we have to differentiate the following functions with respect to x. And in that, the third one is log of x raised to x, log of x raised to x minus cos of x raised to tan x. So what we have to do, we have to differentiate this given function with respect to x, okay? We have to differentiate this function with respect to x. So as usual, what will be my first step? I will write let y equals to, I write this thing as y, so y equals to log of x raised to x minus cos of x raised to tan of x, minus cos of x raised to tan of x. This is my first step, okay? Now here see students, this is something which we are coming across for the first time. I must tell you that this function which you are differentiating, you are coming across such a function for the first time. See, first of all, you have difference of two functions. You have difference of two functions. You see this, log x raised to x is one function and cos x raised to tan x is another function. You have difference of two functions. This is first thing that you have to know. Further, look at these functions. Log x raised to x is a variable raised to variable type. What is this function? See, you have variable in the base and variable in the power, and this is also variable in the base and variable in the power, okay? So these both are variable raised to variable type of functions. Next, you see that in between these two variable raised to variable functions, you have a negative sign. Now this negative sign is of much importance. See, we have a negative sign in between the two. Okay, now because of this negative sign, the idea to solve the problem will change. Okay, it will have a major effect. This negative sign will have a major effect so far as the idea of derivative is concerned. What do I mean by that? Let me tell you that. See this negative sign. If this was not negative, let me tell you, if this was not negative and it was a product sign, suppose if it was multiplication sign, if it was a multiplication sign, then though both are variable raised to variable, okay, variable raised to variable, they both are variable raised to variable, my idea would have been different. My idea of solution would have been different. But here what I'm saying, I have got here negative sign. Now because I have a negative sign here, I'll be going for a total different way of differentiation. Now what do I mean by all this? You will know when I actually start solving it, okay? When I actually start solving it, you will know it. Very good. See, the first thing first. First thing first, if you remember in last lecture, that is lecture number 12D, I suppose, lecture number 12D, what I had told you all. I said that whenever you see variable raised to variable, like I said, if you have f of x raised to g of x type, any function if you see in the form f of x raised to g of x, what you will do is you will write taking log on both sides. You will write taking log on both sides, and you don't have to mention the base of the log because it is understood it is to the base e. You are taking natural log on both sides. So when you take log on both sides, what would you get? You get log of u equals to log of f of x upon g of x, and then this becomes log of f of x raised to g of x. This becomes g of x into log f of x. This is by law of logarithm. You know, log of f of x raised to g of x, log of f of x raised to g of x, what happens is this g of x which is in the power, it will become coefficient. You see this? So g of x will come here, and that's what you are writing. So what happens? What is the advantage of taking log on both sides? Whenever I have variable raised to variable, whenever I have variable raised to variable, okay, variable raised to variable, I take log on both sides because I do not have, or I do not have a specific result for variable raised to variable. I will always differentiate variable raised to variable by using product rule. See how product rule? This g of x into log f of x. Now here I have product of two functions. Okay, f of x is to g of x. What we did, we made it g of x log f of x, and now I can use product rule. So this is the advantage of taking log whenever you have variable raised to variable. Okay, I hope you have followed this part very well. I hope you all have followed this part. Now I come to my solution. Here I have log of x raised to x minus cos x raised to tan x. Now someone would say that it is once again variable raised to variable. Someone would say it is variable raised to variable. See, variable raised to variable, variable raised to variable. And then what they would do, blindly, they will go for this rule, taking log on both sides. They will take log on both sides. Why? Because they see variable raised to variable. Now see what will happen. If I write taking log on both sides, if I write taking log on both sides, if I write taking log on both sides, and I take log, so here I'll get log of y, and this side I will get log of, inside the bracket, see what I will have. I have log x raised to x minus cos x raised to tan x. Okay, you know what will happen now? See students, you just can't do anything ahead. Having taken log on both sides, you are now stuck. You are in a fix. What kind of fix is this? You are not able to go ahead. See, you got log of something minus something. And for your kind information, we have done logarithmic laws. In those logarithmic laws, not a single law gives us the next step for this. I do not have any step ahead for log m minus n. I cannot write anything for log m minus n. Remember, many students think they do it wrongly. You know, they think it is log m minus log n, which is incorrect. You know, it is incorrect. Log of m minus n, you just can't do anything. You can't do anything. Log of m minus n is nothing. It is nothing. You will have to leave it the way it is. You just have to leave it the way it is. Okay. Yes, if I had log of m upon n, then I would have written log m minus log n. If it is log of m upon n, then we do it this way. So here what I'm getting is I'm getting stuck here because I have log of m minus n, and I understand that I just can't do anything. What I wanted was I wanted a log here. See, I wanted a log for this. You know, what I wanted was I wanted a log for this, which I'm not getting. I wanted a log for this, which I'm not getting. So here I tell you, was what I was thinking. I tell you what I was thinking. I was thinking of getting log for this. See, if I had got, this is log of log x. Suppose if I had got log of x raised to x. Log x raised to x it is. It is log x raised to x. If I could have managed to get a log here, it would look this way. And then in next step, what would I write? In next step, this will become the coefficient and it will become x log of log x, x log of log x. This is what I was thinking of getting, but am I getting it? No. Why? Because I am unable to get this log here. Okay, same thing. I'm unable to get a log here. So what I would do, I just cannot do this way. That's what I'm telling you. I cannot take log on both sides. I cannot take log on both sides. Why I cannot take log on both sides? Because I have got a negative sign in between. I told you this negative sign is of much importance. Because I have got a negative sign in between. Similarly, if you had a positive sign in between, remember, if you had a positive sign in between, then also you will not take log immediately, because then it would become of the type log of m plus n. It would become what type? Log m plus n. And once again, you are stuck. Nothing you can do for log m plus n. So what we will do here is we will not take log immediately. So what do we do? See, I tell you, what do you do? I write here, this is equation number 1. I write let. Now I take this as u and this as v. I write them u and v. So I will write let u equals to log of x raised to x and v equals to cos x raised to tan x. This is what I do. Okay. So what is the advantage of this now? If I'm doing it this way, what is the advantage? See, the advantage is that this will become therefore using this 2, I will write therefore y is u minus v. What has y become now? U minus v, because I have taken them as u and v respectively. So y is u minus v, and if I differentiate this with respect to x, I will get d by dx of y as d by dx of u minus v. So I will get dy by dx equals to du by dx, that is d by dx of u minus d by dx of v. And this is my equation number 2. Okay, so what I understand that if I want dy by dx, okay, if I want derivative of y with respect to u, which is this, see, it is y whose derivative you want. That is what you want. You want derivative of y with respect to x, okay, because you have taken this as y. This whole thing which you wanted to differentiate, you have taken it as y. You have taken this as y. So you want dy by dx, and what you understand that dy by dx is du by dx minus dv by dx. So if I want to find derivative of y with respect to x, what would I do? If I want to find derivative of y with respect to x, what would I do? I shall first differentiate u with respect to x, then get derivative of v with respect to x, and then substitute in 2. Okay, so now I understand that it is high time I differentiated, I found these two. It is high time I found these two. Okay, so what am I going to do? I'm going to get derivative of u with respect to x and derivative of v with respect to x, for which what I will do, I will begin with this. You understand? I will go for u. So here I write, see, I write here, consider, I write here my derivative starts from here. I write here consider u equals to log x raised to x. Okay, and now what I do, which we I now what I do, which I want to do, that is I want to take log on both sides. You know, that's the rule. That's the thumb rule. If you have variable raised to variable, you will take log on both sides. Okay. We couldn't take log here for some reason, you know, that I have already explained, because we have a negative sign in between them. So I write here taking log on both sides, taking log. Now I will take log on both sides. So when I take log on both sides, see, what do I get? I will get here log of u, I get here log of u equals to log of log x the whole raised to x. Log of log x the whole raised to x. What will this become? It will now become, see students, it will now become log of u equals to x log of x, x log of log x. And you can check, students, that you have no more variable raised to variable. Instead, what it has become, it has become product of two functions of x. It has become product of two functions of x. So here I write what? I write here differentiating with respect to x. I now differentiate this with respect to x. You know why? Because I'm intending to get du by dx, log u. So it will get me du by dx. Okay. So here I write d by dx of log of u equals to d by dx of x into log of log x. It's going to take some space. So what I will do is I will solve this on a new page. Okay, I will solve this on a new page. So here, see, I have copied the same thing here. Now here you have d by dx of log u. What the function is? It is logarithmic function. But what you notice that the variable is not matching. See, you have d by dx, but this is not x, it is u. So which result will you apply here? You will apply the result of d by dx of log f of x, which is 1 upon f of x d by dx of f of x. So this is 1 upon u d by dx of u. And here I shall be using product rule. See, x into log of log x, u into v rule. Okay, so this is x, derivative of log x. I'm writing the whole thing, but if you want, you can skip this. You can directly write derivative of log x. So x into derivative of log x plus log of log x into derivative of x with respect to x. U derivative of v plus v derivative of u. Next step you have therefore 1 upon u du by dx equals to x. D by dx of log x is, once again, what function? Log function. But it is not log x, it is log f of x. See, you can check the variable is not matching. Okay. So here what you have here d by dx of log x is 1 upon log x. You have here 1 upon log x into d by dx of log of x. And plus here what you have here, you have log of log x into 1. You have log of log x into 1. So this will become, see what it will become. It will become 1 upon u du by dx equals to x upon log x into 1 upon x plus log of log x. So what is next step? So you will have du by dx as, see, this u will multiply on the right hand side is u times, okay, this x and x cancels. Okay, so here you have 1 upon log x plus log of log x, 1 upon log x plus log of log x. And this I write as equation number, I write this as equation number 3. I got du by dx. Okay, if you want, you can write one more step, that is you substitute for y. You substitute for what y is. Okay, so here I just put a line of demarcation, and here I have, so therefore du by dx is u. What's u? What's u, students? U is log x raised to x. So you have log of x raised to x, log of x raised to x, and into this, that is 1 upon log x plus log of log x. That's complete. And this is equation number 3. Now I go for dv by dx. See, I have found this. We are working on equation 2, which says that du by dx minus dv by dx will be dy by dx, which is your aim. Your aim is to differentiate y with respect to x. Okay, so I have already managed to obtain du by dx. Now I'm going for dv by dx, for which what I'll write? I'll now write consider v. As I considered u and got du by dx, now it's time we considered v. That is, v is cos x raised to tan x. What is v? Cos x raised to tan x. So I write here consider v equals to cos of x raised to tan of x. And what I will write? I will write taking log on both sides. I write here taking log on both sides. So when I take log on both sides, I get here log of v equals to log of cos x raised to tan x, and that will be log of v equals to tan of x into log of cos of x. I write, now see, this cos x become the coefficient, and now you no more, you do not have any more the variable raised to variable function. Instead, what you have is product of two functions of x. So what you shall be now doing is, you will now be differentiating with respect to x. So you write differentiating with respect to x. So it will get you d by dx of log v, d by dx of log v equals to d by dx of tan of x into log of cos x. Students, I have said so many times that while writing, I write all the steps, but there are certain very obvious steps which you can always skip. Okay, the skipping of steps should happen to you by on its own. You know, you should not be deliberately skipping the steps. If you know the things, it will happen to you automatically. So 1 upon v d by dx of v. Now here, see, it is u into derivative of v. It is u v. So u into derivative of v plus v into derivative of u. So see, here I will do that directly. So tan x d by dx of log of cos x, that is 1 upon cos x into derivative of cos x, which is minus sin x. See, this is what I meant. You can write it directly. You see this? What is it? It is 1 upon cos x into derivative of cos x, which is minus sin x, plus now you have log of cos x and derivative of tan x, which is sec square x. Now what will happen next? This we will multiply in the numerator on RHS. So here you have, see what you have. You have here tan x, and see this sine upon cos is also tan. You have tan x into tan x. You see this? You have tan x and tan x into tan x. So this is tan square x, and it is negative, so minus tan square x. So you have therefore dv by dx equals to v into minus tan square x. You have the minus tan square x plus log cos x into sec square x plus log of cos x into sec square x. And what is next step that I will do? I'll write what v was. V was cos x raised to tan x. What was v? It was cos x raised to tan x. So I will write therefore dv by dx equals to cos of x raised to tan of x into minus of tan square x plus log of cos x into sec square x. And this is equation number 4. So you got du by dx in 3, you got dv by dx in 4. What's the next step? The next step is you will write here using 3 and 4 into. You will write using 3 and 4 into, you will get dy by dx. So I write using 3 and 4 into, you get dy by dx equals to, okay, you write du by dx minus dv by dx. This is what it is going to be a big answer, right? So here I write, see what is it? Du by dx is log x raised to x, 1 upon log x plus log x. So this is log x raised to x in bracket 1 upon log x plus log of log x. This is du by dx minus dv by dx, which is this. What it is? It is cos x raised to tan x multiplied by negative of tan square x plus log of cos x into sec square x. This is the final answer. This is the final answer, my dear students. You can just go for, if you want to understand it well, you can once again play the video and do so. So you can see it's a huge solution, but it's very simple. It's a huge solution, but it is very simple. Okay, so this is another question in the same, this is another sub question in the same question, that is number 2. It says differentiate. See, this time you have to differentiate sin x raised to tan x plus cos x raised to cot x plus cos x raised to cot x. What is first step? The first step is you will write this as y. Okay. Now you notice that you have variable raised to variable, but you got a plus sign in between. Because of this plus sign, you cannot take log. See, you want to have a log here. That is mandatory. You want to have a log here. Here you want to have a log. Why? So that if you have a log here, this tan x will become the coefficient. Log of sin x raised to tan x will become tan x log sin x. Similarly, you want to have a log here. But if you take log on both sides, what will happen? Log y equals to log of this whole thing. And because of this plus sign, you can't go ahead. So the idea is, you know what we will do. We will take this as u, we will take this as v. So y will become u plus v. So dy by dx will become du by dx plus dv by dx. And then you know what you have to do. You will take u separately, differentiated by taking log on both sides. Once you got this u separately, you can easily take log on both sides. As you saw in the previous question I did, you will get du by dx. Similarly, you consider this v, take log on both sides and differentiate, you will get dv by dx. And then what you will do, you will add du by dx and dv by dx, because you have a plus sign in between them. That will be dy by dx. That will be dy by dx. Okay, now we have another question as number 5. See this. Here we have to differentiate. We have to differentiate e raised to tan x. We have to differentiate e raised to tan x plus log of tan x. E raised to tan x plus log of tan x. And once again, what we have in between them, we have a positive sign here. You can check. We have a positive sign in between them. Fine. Some of you must be thinking that though we have a positive sign in between, but we do not have both as variable raised to variable. See, students, here we have variable raised to variable. Log x is a variable, tan of x is a variable. So here we have variable raised to variable, but this is not variable raised to variable. What it is constant raised to variable. Okay. May it be constant raised to variable. But the thing is, here you have one variable raised to variable. Here you got a variable raised to variable. And because of that, what happens is, taking log becomes mandatory. You know, you need to have a log here. You need to have a log here. Okay. You might think that this can be differentiated, this function e raised to tan x. See, if I write d by dx of e raised to tan x, I have a result for this. Why? Because I will say this is e raised to f of x. I will say that it is d by dx e raised to f of x. So its derivative is e raised to f of x into derivative of f of x, which is tan x, so sec square x. So remember that you do not need log for derivative of e raised to tan x. You do not need log for derivative of e raised to tan x, but you do need log for derivative of log x raised to tan x. Now, because of that, what happens, you have to take log. You have to take log. Even if you have one of the function, you understand this cannot be differentiated unless you have a log here, unless you have a log here. So I understood that I want a log here. So can I take log? See, the first step, I will write let y equals to e raised to tan x plus log of x raised to tan x. Now I understand that I need a log here. So can I write that taking log on both sides? Can I say taking log on both sides? The answer is no. Can I say taking log on both sides? The answer is no. Why? Same reason. Because if I take log on both sides, remember you have a plus sign here. You have a plus sign here. And log of m plus n will just be nothing. It is what it is. You just can't go ahead. You are stuck. So what I'm trying to tell you is, once again, though you do not have both variable raised to variable like the earlier problem, okay, you will have to go for u and v. You will have to go for u and v. Why? Because one of them is variable raised to variable. So you will write let u equals to e raised to tan x. You write this as u equals to e raised to tan x, and v equals to log x raised to tan x, log x raised to tan x. So your what will the function now become? The function will now become, therefore y will become u plus v. Y will become u plus v. Okay, this is 1, and now I write differentiating with respect to x. So I will get d by dx of y equals to d by dx of u plus v, which is d by dx of y or dy by dx as d by dx of u plus d by dx of v. This is number 2. I got equation number 2. So now what do I get next? I'll now get here, therefore, see. So once I understand that dy by dx will be this, now it's all very simple and quite very simple. What is it? I will write let u. So I write here consider, now I'll go for the first one, du by dx. So consider u equals to e raised to tan x. Okay. Is this variable raised to variable? Is this variable raised to variable? No. It is not variable raised to variable. It is e raised to tan x. It is e raised to f of x. It is actually constant raised to variable. So for such functions, should I be taking log? Is taking log mandatory, compulsory? No. You can differentiate this even without taking log. But if you take log, it's not wrong as such. See, without taking log, how it was done, I just showed it to you. You remember, just I differentiated? Yes. But what I will do is I will also take log and differentiate so that you understand both the ways. Yes, you can always take log here, See, you can take log. Taking log is not mandatory, but you can take log. But what about this? Here you cannot, if you don't take log, you cannot differentiate. Here, if you don't take log on both sides, you cannot differentiate. Here you can differentiate either way. So I write here, just for the fun sake, I write here taking log on both sides. See, I will still get the same answer which I had earlier got. So I will get log of u equals to log of e raised to tan of x. And remember, the base here for log is e. So next step, I will get log of u equals to tan of x into log e. This tan of x becomes the coefficient. You know the base is e, so log e to the base e. Though we don't write the base, it is e. So log e to the base e, it is log e is 1. So you have log of u equals to tan, I'm sorry, log of u equals to tan of x into 1. So you have log of u equals to tan x. So I will write here now log of u equals to tan x. So what we will now do is, now see, this is the time when we differentiate. I write here differentiating with respect to x. So I get d by dx of log of u equals to d by dx of tan of x. So d by dx of log u, you know what it is. It is 1 upon u d by dx of u equals to d by dx of tan x is sec square x. Now this u multiplies here. So you have du by dx as u into sec square x. And what was that u? You remember what that u was? U was e raised to tan x. So you will notice that you are getting the same answer which you would have got had you differentiated directly. But why did I did it by taking log? I just wanted to tell you that even if you take log and differentiate, you will get the same answer. Now I go for, see, I got du by dx. Now it is time I differentiated for dv by dx. I'll write consider v equals to log x raised to tan x. I write here consider v equals to log of x raised to tan of x. So I write, now here taking log is mandatory. Okay, I can't say that I have a choice, no choice. So taking log on both sides, on both sides. So what do I get? I get here log of v equals to log of log x raised to tan of x. So this will become now, so here I get, therefore log of v equals to tan of x into log x, tan of x into log x. This tan x becomes the coefficient. What's next step? Now I write differentiating with respect to x. Why? Because I notice that there is no variable raised to variable. Instead, it is product rule. So I write here differentiating with respect to x. So this is d by dx of log v equals to d by dx of tan of x into log of log x, tan of x into log of log x. This will get me, so d by dx of log v, it is 1 upon v into d by dx of v. And this is what? It is tan x d by dx log x, tan of x d by dx of log x, which is 1 upon log x into derivative of log x, which is 1 upon x. I'm doing it directly now. We have done enough problem. Plus, see, tan x derivative of log x, I have done it. Plus log x derivative of tan x. So I have log of log x into sec square x. So next step I get here, therefore dv by dx would be, you multiply v here, and this is, you get tan x divided by x log x plus log x into sec square x. Okay, so now I substitute for v. What was v? V was tan x raised to log x. So I get here dv by dx is tan of x raised to log of x into tan of x upon x log of x plus log of log x into sec square x. This is equation number 4. What do I write now? I write here using, I write here using using 3 and 4 in 2. What do I mean? What I mean is, I write here, see, I got here du by dx, I got here dv by dx. I substitute these two in one. I'm sorry, in two. What is that? dy by dx is du by dx plus dv by dx. You just have to add them, and that will be your final answer. Definitely, it's going to look big. So what will be your dy by dx? Dy by dx will be du by dx, which is e raised to tan x, e raised to tan x into sec square x, e raised to tan x into sec square x plus dv by dx, which is quite big, you know. It is, I'll try to manage to write in this only, tan x raised to log x in another bracket, tan x upon x log x, tan x upon x log x, x log x plus log of log x into sec square x, and the brackets complete. This is your final answer. I hope you all followed it. If you want to understand it much better, you can just play the whole video once again. Okay, thank you.